Okay, I want to do this one more time. Okay, so let's do it one more time. Let's find this area. This is again the function f of x is equal to minus x squared plus 4. And we're going to find this area. So what's that between? That's between x equals -2 and x equals 2. Okay? I'd like you to do all the work. Okay? Go ahead and compute. So let's look at the setup here. This is the definite integral from -2 to 2 of minus x squared plus 4 dx. I didn't write x equals -2 to x equals 2. You don't have to write that. You do have to put the numbers there. Okay? But there will be times where I will rewrite the x equals because I want to emphasize that these are in terms of the variable x, because we're going to do changing of variables here soon. Okay, so it's kind of cumbersome to write x equals every time, but sometimes in fact, I would encourage you until you feel really, really comfortable with this, keep writing the x equals. Okay, so then the anti-differentiation step hasn't changed. 1/3 x cubed plus 4x. Boy, I'm getting tired of that. From -2 to 2. So let's see here. This would be -1/3 times 2 cubed plus 4 times 2. That's for the upper limit of integration, minus the lower limit. -1/3 times -2 cubed plus 4 times -2. And I do want to actually see how all this computes out, so let's actually crunch it. Let's see here. Actually, we did this before, but let's see. 2 cubed, that's -8/3 plus 8, which before was 16/3. Okay, minus, let's see, over here I'm going to have -2 cubed over 8, so I'm going to get -8/3 minus 8. That's going to give me -16/3, but what? It's minus a -16/3. What do I end up with? Okay. I want you to convince yourself that that answer makes complete sense. What were we doing? We were computing this area. How does this area compare to this area right here? It's twice the amount, right? By symmetry. Specifically, this function is symmetric about the y-axis. Okay. And since it was symmetric about the y-axis, we can make some sort of statement. So I want you to make this statement. Suppose f is even. Okay? Now, if you're not completely sure what an even function is, you might want to spend a little bit of time reviewing it. This is not a property that shows up all the time, but it is a helpful little time-saving property. Okay? Suppose f is an even function, then the integral from -a to a of f of x dx is just twice the integral from 0 to a of f of x dx. That's what we just discovered. Okay? Let's make sure this makes sense. There's two things I'm requiring here. What are the two things I'm requiring? I'm requiring f to be even, and what's the other one? Let's look at those limits of integration. They've got to be equal yet opposite. If that's the case, then rather than computing this definite integral, you can compute this one. Does that save you any time? To be honest, it doesn't save you that much time, but what's beneficial about this? What's beneficial about this? What do we get to plug into as a limit of integration? 0. We've already seen, oh, it's a lot easier to plug in zeros more often than other numbers. Okay? So that's where that's a little bit of a time saver. All right, next page.